Earlier in this section, we had a video dedicated to finding the distance from a point to a line. Well, now that we are discussing planes, let's have a similar calculation. Let's find the distance from a point to a plane. So this is, I'm not going to derive the formula, I'm just going to present the formula to you. The distance, so point S to a plane with normal n at P, is you find the vector from P to S. You find the normal vector. You divide out, you turn the normal vector into a unit vector by dividing it out by its length. Take the dot product of those two, and this isn't length, this is absolute value, just to make sure that we don't have a negative length. Just to kind of I think it's worth drawing a picture here just to make sure that we see what's going on. So, we have some plane here, P. So, well, I'll use a script TP here. This P is actually going to be the point. We have some S point off of the plane. We want to figure out the distance. So we choose a point P on the plane. We can choose any point we want to. We We draw this vector. Let's say this is the normal vector here. This is PS. So do PS, the vector from P to S here, dot product with the normal vector. Let me, now it's a normal vector that's been scaled appropriately, so it's a unit normal vector. Okay, so let's go ahead and get into the example of this. So find the distance from the point 113, that's our S, to the plane 3x plus 2y plus 6z is equal to 6. So first off, let's realize that we need a normal vector. And so how do we find a normal vector? We can get n by simply taking the coefficients of x, y, and z respectively. So 3, 2, 6. This is our normal vector. Well, we also need to find the length, the magnitude of the normal vector. So the length here is going to be the square root of 3 squared plus 2 squared plus 6 squared. And that's going to be 9 plus 4 plus 36. And that's 49 under the square root. So the length here is 7. Okay, so we have our normal vector, we have our length, we have our point S is given to us in the problem. Now the thing is that we need a point. And we can choose any point that we want to. We can choose any point that we want to for our purposes here. Probably the easiest way to do this is to find an intercept. So that would be set a couple of, set x and y to 0 and figure out what z has to be, set x and z to be 0, and figure out what y has to be, set y and z to be 0, and figure out what x has to be. Let's have x and z be 0. If x is 0 and z is 0, our equation is 2y is equal to 6. And so our point here is 0, 3, 0. Okay, so if we're using this as P, we want a vector from P to S. And so that would be 1 minus 0, 1 minus 3, 3 minus 0. So that is 1, negative 2, and 3. And so now using the formula, it's just going to be the dot product of our PS vector with a normal vector, divide that by the length of n. So PS dot product n is going to be a dot product of this with this will be 3 times 1, 2 times negative 2, and 6 times 3 is 18. So that would be 18 plus 3 is 21, minus 4 is 17. Okay, and so then our distance here is going to be 17 divided by 7. Absolute value of that, everything in sight is positive, so we just have 17 over 7. I should point out that the way I computed this was ever so slightly different than what I wrote here, but that shouldn't bother us. The way I just computed it was I did the PS vector dot product, the normal vector, and then I divided by the magnitude of the normal vector. These two are equal to each other by dot product properties. I said it doesn't matter what point that we choose here. I think maybe it would be instructive. Let's just choose a different point. If we set y and z to be 0, we would have 3x is equal to 6, and so that would be x is equal to 2. So if instead, let me call it q here is the point 2, 0, 0. So vector from q to s, where s is 1, 1, 3, would be 1 minus 2 is negative 1. 1 minus 0 is 1, 3 minus 0 is 3. And so everything works out well. QS dot product n, where n here is 3, 2, 6. This would be 3 times negative 1 is negative 3. Let's see here. Yeah, so 3 times negative 1 is negative 3. 2 times 1 is plus 2. 3 plus 6 is, 3 times 6 is 18. Once again, this ends up as 17 for our dot product here. And so the distance would be absolute value of 17 over 7, which again is 17 over 7. So it genuinely does not matter which point you choose on the plane. If you crunch through everything, you'll get the correct answer.